Okay, we're going to take a look at a couple of examples for solving differential equations, and these are what we call separable differential equations. And so what we're going to do is separate the two variables. And so if you look here, I've got dy dx equals e to the 2x minus 2y, and that of course is the exponent. So what we're going to do is we're going to actually employ the use of exponent rules. So this may take you back to algebra 1 here, but subtraction of exponents really means division. Okay, so it actually looks something like this. And then what we're going to do is we're going to kind of do this kind of a cross multiplication, if you will, and we're going to separate the two variables. That's why these are called separable differential equations. Okay, so once I've done that, I get e to the 2y and then dy, and then I set that equal to e to the 2x dx. And what I'm going to do is I'm actually going to integrate both sides. And once I've done that, I'm going to solve, in this case, for y. So let's go ahead and begin with that process and integrate both sides. So when I integrate this right here, e to the 2y, what I'm going to do is I'm going to do some u substitution. And so I'm going to pick my u to be 2y. And so if I think about my du, it's going to be 2 dy. So I need a 2 here, and by consequence, I need a 1/2 on the outside. And similarly, the same thing is going to happen for the x, because they're actually identical, the difference being x and y. Okay, so now when I integrate this, it's actually really simple. I end up with 1/2 e to the u du on both cases, or in both cases. And so I end up with 1/2, in this case, e to the 2y equals 1/2 e to the 2x. Okay, so in both cases I end up with that. Now I will write in only one constant of integration. They both have a constant, so suppose if you had a constant on the left and you moved it to the right, you'd have some new constant. So we only need one. All right. Now what we're going to do is we're going to try to get rid of this fraction here. And what I'm going to do is multiply everything by 2. This is going to give me e to the 2y equals e to the 2x plus, and now, yes, you will have some new constant, 2c, but again, it's just some arbitrary constant, so we'll continue to call it c. Now again, we're trying to solve for y. So what we're going to do is we're going to take the natural log of both sides of this. So I'm going to adjust this a little bit just so I have enough space. I take the natural log of both sides. Okay. And in doing so, the natural log gets rid of the base e there. Okay. Not on the right-hand side of the equation, but on the left. And I'm left with 2y equals the natural log of e to the 2x plus c. Okay. And then I'm going to divide everything by 2, which is equivalent to multiplying by 1/2. Okay. So I have obtained a solution, which is y equals 1/2 of the natural log of e to the 2x plus c. Okay. And it looks just like that. Okay. And it looks just like that. So nothing really big. It's just some basic integration techniques and working to put all of that together. Okay, so that is right there the solution to the differential equation. All right, let's go ahead and take a look at one more example. Okay, here is another example of a separable differential equation. So what we're going to do here is, again, we're going to employ this method where we kind of cross multiply. All right, now you're going to see this one is a little bit different than the last one. All right, and we're going to have to do a little bit of work in order to get this done. So we're going to have x dy equals 3y squared dx. Now we still need to go about separating all of this. Okay, so what we're going to do is we're going to actually divide both sides by x to eliminate it from the left side. But similarly, we're going to divide both sides by 3y squared to get rid of it from the right side. And so we're going to eliminate x on the left and 3y squared on the right. And we end up with another set of differentials. That is to say that dy over 3y squared will equal dx over x. And this is, again, something that we need to eliminate. So what we're going to do first, before we integrate, I want to clear this 3 out of the way. So I'm going to multiply everything by 3. And so let's see what happens there. If I do this, I get dy over y squared, the 3 eliminates, and then I end up with not so big of an issue, 3dx over x. Okay, now I think it's good to integrate. And so doing this, I think you should start seeing one side is relatively easy. It's a power rule deal. And the other side is a natural log case, but that's perfectly all right. Okay, so I'm going to rewrite this integral before I move any further, at least the left-hand side, and to write it as y to the negative 2. And then we're going to have the integral 3dx over x. So the left side, relatively easy, but so is the right side. The left side's just a power rule integral. That is, we're going to add 1 and divide by the new power. So negative 2 plus 1 is negative 1. So we have y to the negative 1 multiplied by a negative 1. And then we're going to set that equal to, well, we know we're going to have a 3, and the integral of dx over x is the natural log of x plus the constant of integration, c. So now what we end up with is a negative 1 over y equals 3 times the natural log of the absolute value of x plus c. And so what we're going to do is what I recommend. Okay, you can pretend all of this is over 1, and then you can kind of cross multiply. This goes that way, this comes this way, and you end up with a solution for y. And that is to say that y will equal a negative 1 over 3 times the natural log of the absolute value of x plus c. And it looks just something like that. Okay, and really not much to it. This is a general solution anyway of the differential equation. And you have, again, if you were given an initial condition, you could figure out the constant of integration. But in this case, we don't know it, but it's not terribly difficult anyways. Just, you know, some algebra steps involved at the very beginning. Otherwise, integration techniques that you should already be familiar with. So, as always, I hope this video was helpful. And remember, like and subscribe.